Hello everyone and welcome to today's webinar entitled Magnetic Levitation for Electromagnetic Energy Harvesting. My name is Ali Vakilian and I am an electrical motor design expert at EMWorks. EMWorks is a leading provider of electromagnetic simulation software for electrical and electromagnetic design. Let's have a look on today's webinar agenda. First, we will have an introduction. Then we will talk about understanding magnetic levitation, energy harvesting, magnetic levitation for energy harvesting, and some case studies. Then we will talk about EMWorks Solutions, and we will have a conclusion. We will mention the references, and finally, we will have a question and answer session. Magnetic levitation energy harvesting utilizes ambient vibrations or movements which are naturally occurring and readily available in the environment. By converting this vibration into electricity, it promotes sustainability by utilizing renewable energy sources and reducing reliance on traditional power generation methods. Energy harvesting through magnetic levitation enables the generation of power in localized area. This decentralized approach is particularly beneficial for off-grid locations or remote areas where access to centralized power grid is limited. It allows for self-sustainability and reduced dependence on external power sources. Magnetic levitation, also known as MagLev, is a fascinating technology that enables objects to float and move in a stable manner without any physical contact with a supporting surface. Magnetic levitation relies on interaction between magnetic fields and specially designed objects or materials. By utilizing the repulsive or attractive forces between magnets, magnetic levitation system can achieve levitation and stability. To categorize the magnetic levitation, we can divide it into two main types: electromagnetic levitation and superconducting levitation. Electromagnetic levitation involves the use of electromagnets or solenoids to generate magnetic fields. On the other hand, superconductive levitation utilizes the unique properties of superconductors, which exhibit zero electrical resistance at extremely low temperatures. Let's have a look on a working mechanism. The working mechanism of magnetic levitation systems involve in the following steps: A. Levitation, and B. Stability. In an electromagnetic levitation system, when an electric current flows through an electromagnet, a magnetic field is generated. This magnetic field interacts with the magnetic fields of a permanent magnet or another electromagnet, creating a repulsive force that counteracts gravity. This force enables the levitation of the object above the magnet. To ensure stability, feedback control systems are often employed. Sensors detect the position of levitating objects and provide feedback to adjust the strength and orientation of the magnetic field. Magnetic levitation has several practical applications, including high-speed MagLev trains, magnetic bearings, energy storage on flywheels, levitating displays, and gadgets. Energy harvesting refers to the process of capturing and converting ambient forms of energy from the surrounding environment into usable electrical energy. It involves harnessing energy from sources such as light, heat, vibration, motion, electromagnetic fields, or radio frequency signals, and converting them into electrical power. In the context of renewable energy, energy harvesting plays a significant role in augmenting and diversifying the available source of sustainable power. Here is why energy harvesting is significant in the context of renewable energy. Energy harvesting enables the capture of energy from ambient sources that are readily available in the environment. Also, energy harvesting technologies are typically environmentally friendly, as they harness renewable energy sources of energy. Energy harvesting is particularly valuable in remote or off-grid areas where access to the conventional power infrastructures is limited. Many modern electronic devices such as sensor, wearables, and Internet of Things or IoT devices require very low power to operate efficiently. In this case, we can use this levitation harvesting energy. Energy harvesting technologies can be designed to be scalable and easily integrated into various applications and environments. Finally, energy harvesting offers the potential to reduce or eliminate the reliance on batteries for powering electronic devices. Magnetic levitation can be employed as an innovative approach to energy harvesting, offering unique advantages and opportunities for sustainable power generation. Here's an explanation of how magnetic levitation can be used for energy harvesting. Principle of magnetic levitation. Magnetic levitation utilizes the repulsive or attractive forces between magnets to suspend an object in the stable position without physical contact. This principle forms the basis for energy harvesting through magnetic levitation. When an object levitates using magnetic forces, any vibrations or movements it experiences can be converted into electrical energy. To convert the vibrations energy into electrical energy, electromagnetic induction is employed. Coils or conductive windings are incorporated into the levitating object or the surrounding structure. The induced electric current can be captured, rectified, and stored or utilized to power electronic devices or charge a battery. Magnetic levitation-based energy harvesting typically consists of a magnet or magnets and coils, which are configured in various topologies to optimize energy conversion efficiency. Here are some of the main topologies that used in magnetic levitation energy harvesting. The single coil topology, the bistable topology. In the single coil topology, a single coil is used to capture the magnetic field variations induced by the relative motion between the magnets and the coil. Bistable energy harvesting utilizes two magnets and two coils. The magnets are positioned such that they can attract or repel each other depending on their relative position. The multi-coil topology employs multiple coils and magnets arranged in specific configurations. Axial flux topology: in this configuration, the magnets and coils are arranged in a disc-like structure with the magnets mounted on a central rotor and the coils surrounding them. In the radial flux topology, energy harvesters have a similar structure to the axial harvester, but the magnets and coils are arranged in a radial configuration. Magnetic levitation-based energy harvesting has potential applications in various fields. For example, structural health monitoring or transportation vehicles. Vibrational energy harvesting from infrastructure or machinery vibrations can power sensors for structural health monitoring, providing real-time data on the condition and performance of buildings, bridges, or equipment. Vibrational energy from vehicle suspensions or road vibrations can be harvested to power onboard sensors, wireless communication systems, or charging small electronic devices within the vehicle. To mention other applications, we can mention wearable technologies and Internet of Things. Magnetic levitation energy harvesting can be integrated into wearable devices, harnessing the wearable's body movement and ambient vibrations to power smart watches, fitness trackers, or other wearable gadgets. Energy harvesting through magnetic levitation can provide a sustainable power source for IoT devices, enabling autonomous and self-powered operation without the need for battery replacement or external power sources. The electromagnetic vibrational energy harvesting system consists of coaxial cylindrical permanent magnets and coaxial coils. The floating magnet oscillates or vibrates in response to external forces such as vibrations or wind. The polarity of the magnets is arranged in a specific manner to enable the central magnet float while its lateral motion is constrained by enclosing it in a hollow plastic tube. Here we can see 3 case studies of magnetic levitation. Single coil, single floating magnet. The middle picture is 2 coils, single magnet, and finally 2 coils, multi-magnets. Now let's have a look on EMWorks Solutions and what EMWorks offers. EMS for SolidWorks, an advanced FEA tool developed by EMWorks, helps with the optimization of energy harvesting process by considering the magnet properties, geometry, and coil arrangement. EMS analyze factors like magnetic flux density, field gradients, and interactions between magnets and coils. This analysis aids in optimizing the magnet configuration and coil design for efficient energy conversion. There are several important outputs that can be investigated to assess the performance and effectiveness of the system. Here are some key outputs to consider. The induced voltage is a result of relative motion between the magnetic field and the conductor within the system. It represents the electrical energy generated through the conversion of mechanical energy. The restoring force refers to the force that brings the magnetically levitated object back to its position after it has been displaced. The magnetic field optimization plays a crucial role in maximizing the performance of the system by optimizing the magnetic field. You can enhance the energy conversion efficiency and increase the power output of the system. Here we can see some results of simulation of the magnetic levitation using EMS. In the diagram, we can see the force vs displacement of the central magnet. We can understand the force will increase in both ways when the central magnet gets far from the central position. In this diagram, we can see the induced voltage or back EMF induced in the coil when the central magnet is moving. The EMS software can provide the magnetic flux density in the environment too. Here we can see the magnetic flux density distribution while the floating magnet moves. This picture illustrates the magnetic flux density distribution in the section of the coils and magnets in the levitator. One of the mechanical output of the EMS software is the force. Here we can see the restoring force of the central magnets when it vibrates or have a displacement. As we mentioned, we can have two coils or multi-coils in our system. Here we have the induced voltage in the coils when the central magnet moves. As we can see, the voltages have almost the same amplitudes, but the phase differs from one coil to another coil depends on the position of the coil. In this slide, we can see the magnetic flux density variation inside the floating magnet. The magnetic flux density distribution inside the harvester system is shown in this slide. EMS software will help us to measure the magnetic flux density to be sure that if we have any saturation in the system or not. For example, in this slide, we can see the maximum flux density on the edges of the magnet is 1.2 Teslas. So we can be sure that we don't have any saturation in our system now. Another simulation is conducted to show the uniform magnetization in floating magnets. Here we can see the force versus displacement of the magnets. This force will restore the magnet's position. Instead of uniform magnetization, this simulation shows the effects on Hallback magnetization on the restoring force. To compare the results and compare the magnetic flux density distribution, we have sectioned the whole system both in Hallback magnetization and uniform magnetization. With comparing the distribution, we can find the best option depend on our system and our limits. Now let's have a conclusion. The analysis and simulation of a 3D model of MagLev vibration-based energy harvester system using EMS for SolidWorks, powerful finite element method tool offers significant advantages and insights for design optimization. EMS facilitates magnetic field analysis, providing a comprehensive understanding of the magnetic interactions within the energy harvester system. By studying factors such as magnetic flux density, field gradients, and magnet coil interactions, engineers can optimize magnet configurations and coil designs to enhance energy conversion efficiency. Here are the references that we used in this webinar, and in this section you can ask your questions and we answer all of your questions in the chat box. Thank you all for joining this webinar. Have a good time.